Yes, good morning. Today we are going to discuss on the next part of the topic, that is solution. As in my last video, as I have stated, the definitions, the formulas of molality, mole fraction and everything. Today we will be taking one of the numerical examples to solve how to find out the molality. There is a numerical, find the weight of urea required in making 25 kg of 0.25 molar aqueous solution. Now see, in this sum it is being asked to calculate the weight of urea. So the formula of urea is NH2CO NH2. The molecular weight of nitrogen is 14 plus 2 hydrogen, carbon is 12, oxygen is 16. Again it is 14 plus 2, so it becomes 28 plus, it is 28, 16 plus 28 plus 16, it becomes 32, 32 plus 28, it becomes 60 gram. So 60 gram is the weight of urea. What is the molality given? 0.25. What is the weight of the solvent? 25 kg. According to the formula, molality equals to WB by MB into WA. Molality is 0.25. Weight of the urea we need to find out. Molality is 60 and weight of urea is, or the weight of the solvent is 25 kg. So 0.25 into 60 into 25 equals to WB. So this is how we need to solve out the numericals based on molality, and there are plenty of examples in the NCERT. From there you can easily find it out. Now the next part of the topic, or the next thing is, as I had discussed with you in the last class, that solubility, we always know that solute plus solvent is solution. Now always remember, a solution is a dynamic process. Dynamic process means, I am giving you an example. Let a solute be having A and the solvent be B and B. So from here in a solution we get AB as a solution. Now there are two processes by which a solution can proceed. One is when a solute and solvent mixes, it forms a solution that is known as dissolution process. In dissolution we get that A and B when mixed up together it forms A and B. And if we reverse it back, means when the solution, if I want to get back the solute and the solvent from the solution, then that phenomenon is known as crystallization. Now crystallization, how we are getting it? We are getting it, you can get it as AA or BB. Means we are, by the help of the solute and the solvent, when solution is being formed, we call it as dissolution process. And when we are changing the solution to solute and solvent, we call it as crystallization process. Now, if the temperature of a solution is increased, what will happen? If the temperature of a solution is increased, let us take the example of sugar and water. What would have happened? we normally see that a sugar does not dissolve much more at a room temperature. But if we increase the temperature, means if we boil the solution or the solvent, we will be finding that more amount of solute or means sugar gets dissolved into that particular solvent. And in this way we can say that as the temperature increases, solubility of the solute in the solvent increases. This is what we are calling as the temperature increases. Now let us take an example of or another thing, pressure. When do we talk about pressure? Pressure means when the pressure is always applicable for a gas when dissolved in a liquid, but it is never soluble or it is never applicable for solid and liquid because they are incompressible, means they cannot be compressed. And therefore let us take an example. I have taken a solution where there is a liquid and there are certain gas particles present onto the surface. Now at a particular temperature, what we will be seeing at a particular temperature, we will see that this gas will be getting dissolved into this liquid, and the pressure at which this gas molecules that are present onto the surface of this liquid will creating a pressure onto this liquid. This pressure is known as partial pressure, which we can denote as P0. Now the next thing is that from here Henry's law states. Henry stated a law. He said that partial pressure of a gas is directly proportional to the mole fraction of the gas. Means P0 or P is directly proportional to the mole fraction of the gas, or P is equals to KH into mole fraction. Over here KH is Henry's constant. Remember one thing, Henry's constant does not have a unit of mole fraction because mole fraction is a ratio. So whatever the unit of pressure you will be having in the sum, that will be the unit of Henry's constant. Means if we calculate pressure in bar or we calculate pressure in atmosphere, so that would be the unit of KH. Now remember one more thing, that KH for every gas at a constant pressure depends upon the nature of the gas. Depends upon the nature of the gas. Remember this thing. So this is what it is being stated. It depends upon the nature of the gas. So everywhere Henry stated that for each and every gas at a constant pressure, we have to see the nature of the gas, that what type of a gas we are using it, and based on that the Henry's law constant we are calculating. Now remember that KH is more. When it is more, at that time mole fraction of the gas will be what? Will it be more or will it be less? It will be less. Solubility will be less. That means when the value of KH for a particular sum, if you are getting it more, then remember that the solubility for that particular gas will be less. Similarly, when the Henry's constant is less for a particular gas, then solubility will be more for that particular gas. Now, where is the application of Henry's law? Henry's law is particularly applicable for the sea divers. When they dive deep into the bottom of the sea, at that same time the atmospheric pressure, along with that the cylinder that they are carrying, in which oxygen is being carried along with them, that pressure, both are applicable. So when they are going deep into the sea, it's quite comfortable for them to breathe easily. But when they are coming up to the surface, at that time, along with the oxygen, nitrogen is also present in the gas cylinder. And what happens? Nitrogen does not have a higher rate of diffusion into the blood. Therefore, it is quite difficult for the sea divers to breathe easily, and it can cause a lot of breathing problem to the sea divers. So this is one of the biggest problems. When the sea divers come up from the bottom of the sea, they face a difficulty in breathing. There are a few more examples, like the cold drinks bottles. What do we see? That the pressure is applied. These are the gas molecules that I have stated. These are the gas molecules, and if this is the cold drinks bottle, then pressure is always being created